Welcome back. This is lesson 5 of week 27 and it's the final lesson of year 1. In this lesson, I want to introduce briefly a final data structure called a record, and I also want to talk about how we can approach exam questions that deal with topics that we haven't learned that well. So in this lesson, I want to look back at a concept of entities and how we can store the attributes of entities. This is something that records have got in common with object-oriented programming. Records aren't quite the same as OOP classes, and there are a range of different software choices we've got that would let us work with records. And I want to also look at some questions about records taken from past exam papers and to discuss how we would deal with exam questions on topics that we aren't that confident about. So, records store information about entities. So what are entities? Entities is just a general term in computing for anything that we can store data about. So in my pictures here, we've got entities that are humans, entities that are animals, but entities could also be physical objects. They could be events, for example, places. And we store data values. It's an observation that data values are always attributes of something. So here's an example. Supposing that our entity was an event, let's say an outdoor concert, some of the attributes of that event might include its location, its date, the list of performers and their timings, and the price of the ticket. So a range of different sorts of data, but they all relate to this particular event. Similarly, you're an entity and you have lots of different attributes such as your age or your username in social media, and these are all attributes of you as an entity. A database is a way of storing the data about different entities, and one record of a database is typically all the information about a particular entity, whereas the fields of the database are individual attributes or data items. So in this picture, you can see some forms which allow us to enter data values about particular entities. The simplest way to store this information would be in what we call a flat file, which would be a simple table structure of rows and columns. The rows are records, that is, each row stores information about a particular entity. These are sales in this example. And the columns are individual items of data, for example, the quantity of items being sold. So a flat file database, this is the simplest way that we can store records. Here's an example, a database table storing records. How many attributes or fields are there here? There are 5 attributes because there are 5 columns to the table, and the blue text at the top of the column tells you the names of the different attributes. And there are 8 records, so 8 different individual, they're cartoon characters, aren't they? 8 individual characters are shown in this table. When we're dealing with databases, records of information, there's a number of different software options that we've got. I just showed you how we can store a flat file in a plain spreadsheet structure. That's perhaps the simplest way to store data records. There's also more complex database software available, and that allows us to create multiple linked tables. We're certainly going to learn a lot more about that next year. And there's a programming language, SQL or structured query language, which is specifically designed to help us to work with databases. Again, we'll learn that next year. You don't need to know it now. And finally, some programming languages, not Python, but some programming languages allow you to create and define a record data type. Now, records are in the syllabus for A-level computer science, so questions about records can come up in the exam. So I just want to briefly review how we might cope with that, and also this will help us to develop skills that will be of greater, more wide use. Perhaps the simplest question they can ask about records is just to define what a record is. So, as you can see from what we've already looked at, a record is a group of data values called fields or attributes, and each one of those attributes has got a name, such as age or address. As you will have seen, the attributes can be of different data types. Some might be integers, strings, Boolean, or whatever. So that's quite similar, isn't it, to an object in OOP? So like an OOP class, a record allows you to store data as attributes of entities, and we can use a range of different data types in relation to the same entity. So far so good. That's very similar to an OOP class. However, there are differences. An OOP class has methods, whereas a record doesn't have methods. It's just a collection of data values. But here's a harder question that came up in a recent exam. They asked you to create a record structure. And in the question, they started by giving us this template for a record structure. Now, this question's not going to come up again, but I think it illustrates something that you might see in the exam. That is, they have told you, they've given you a template for the code you've got to write, and all you've got to do is use that template. So this template begins with the word record structure, and it ends with this kind of composite word, end record structure. Then we've got to add the record structure name, whatever that is, and then we've got to list all the fields, giving the field name a colon and the data type of that field. So that is a structure. The 3 dots below field name mean that could be repeated one or many times. So there might be many fields, and we declare each one below the other. And you'll see as a result, we'll end up with something that looks quite a lot like the constructor in OOP, but not quite the same. So we're going to copy that. If you want to pause the video and note that down, or later on you can scroll back and have a look at this. In the exam, of course, it would be right there on the page for you to check against. And here's the rest of the question. They ask you to declare a record structure for a record called items. And it's got 4 attributes, and it's given you the name of each attribute and an example of the data that would be stored, so that you can use that to work out what data type you need. So putting that together, the template that I've just shown you and these facts about what attributes we need to store, we can declare a record structure. So I strongly recommend that you pause the video now, check the data that you've been provided with, and try and answer this question. I'm going to show you an example correct answer on the next slide in a moment or two. So here's a model answer. You can use it to mark your own work. Give yourself 1 mark for each line that you basically got right. You should your first line should start with the word record structure and then a suitable name items, and then for each subsequent line you should list each of the attributes, giving a suitable attribute name and a suitable attribute type. So that's up to 5 marks there. And here's another example question. Once again, they've given us a template for what our answer must look like. New records may be created using the following syntax: the name of the record identifier, a colon, and the name of the record structure name. And then for each of the fields, the record identifier, for instance, box 1, a full stop, and the name of the field. We've already defined the field names in our previous question. Then an equal sign and the data. And what data to use? Well, it's immediately below the template. A new item, the identifier will be box 1, the names box, the cost, the date, and transferred. All the data that you need is provided below the template. So now you've got to put those facts into the template structure provided. Remember, there'll be 4 field names. Use the field names that you already decided on in the previous question. So this is a follow on from the previous question. Let's have a look at what that looks like now. Here's a model answer. The item is called box 1. It's of the items data type, and it's got 4 attributes with the given data values provided in the question. How would we mark that? Well, I'll show you that on the next page. If you get the first line right, you declare an item called box 1 using the correct record identifier. And then every variable begins box 1 dot, and then you give that would be a second mark. And then if you've correctly given the name of the attribute, the equal sign, and the correct data, then you get that third mark. Now those are 3 quite hard marks to get, I think, but it illustrates how if we look at the question carefully and apply the data and the information in the question, we can answer questions even about unfamiliar topics. Okay, so this was the last lesson of the year, and I just took that opportunity to talk a little bit about exam tactics. If you're my student, I've got some further examples of exam questions about records which we can use to practice. And for all my listeners, I would recommend you go to the exam board website and have a look at past papers and the mark schemes and practice answering questions. Okay, so this is the end of year 1. Plenty more to learn in year 2, which is on a separate channel in YouTube. So bye for now.